All right, guys. So now this can be a little complicated, but here we go. All right. When you see a wedge like that, a triangle, that means it's coming out. Here's the paper. It's coming out, like at me. All right. When I see these little dashes, that means it's going into the paper or behind it. And then if I just draw a straight line, that's in the plane of the paper. All right. So this is methane right here, natural gas. All right, see, it's carbon, 4 single bonds to hydrogen, not a big deal. So here, the way that it spreads out looks like this. You can see this hydrogen is going behind the paper, this hydrogen is going in front of the paper, and then this hydrogen and this hydrogen are in the plane of the paper. All right, so that's what we have here. If we move over here, this is acetylene. Excuse me, it's not, it's ethane. We have a carbon to carbon double bond, right? But if we want to draw it three-dimensionally, like how this things are spatially arranged, we get this. This is called trigonal planar because it's like a triangle there and it's in one plane, so everything's sitting flat. All right. But we could draw it differently. We could draw it here like this. And all it is I took that double bond and I turned it. That was all. Nothing crazy. All right. This one's called tetrahedral. Down here, this is acetic acid, and acetic acid has a lot of different stuff going on. It's actually a really small molecule, but this first one right here, this is tetrahedral. What we will try to do is keep carbons that are connected to each other in the same plane, or else it gets very complicated. It doesn't always work out, but we're going to kind of make some approximations later. This carbon right here, that is trigonal planar. See, we got the three there. And this oxygen right there, we call that bent. It's just two things in the plane of the paper, bent line, no big deal. This is acetylene, this is linear, not a big deal. Triple bond between the carbons, there we go. All right, down here, this one, I put a little asterisk here because this is benzene. And this little guy right here is in so much stuff. This structure comes up all the time in the compounds we're going to be talking about. And so you can see every carbon is trigonal planar. So it's flat. It's a way that we can keep things in a certain alignment. This is ammonia. This is called pyramidal. All right, don't worry, we're not going to get too much in the names, but you can see that there's this lone pair here. This hydrogen is coming out. The hydrogen is going in. This is water. This is bent. There's only two bonds. So what we'll start with, because I know that I'm going to run out of time here, we'll do these 6 and then finish it up. All I'm doing is drawing these. All right, and I got to teach you how to do organic drawing because a lot of drawings in chemistry are just these lines right here. So every line, or excuse me, every little point here in this line is a carbon atom. This is propane, just like what you get for your grill. There's 3 carbons here, and all of those carbons are tetrahedrally bound. I know this because this carbon has 1, 2, 3, 4 bonds. Tetrahedral. But we ignore hydrogen. We just don't draw it because it takes up a lot of space and it's kind of annoying. So here we have 1 carbon, 2 carbons, 3 carbons. And this is that bent line that we'd see here. See, it's like here to here. So that's what we have here. It just looks like this. Octane, we have a huge dependency on this. If you drive at all, it's created from crude oil. This has 8 carbons in it. You can see I'm starting to count right here. This guy, the end. 1, 2, 3, 4, 5, 6, 7, 8. There's 8, and it's only carbon and hydrogen, so I don't draw those. And we just get this nice squiggly line for octane. Acetylene, we already drew this one. Pretty easy. This is formaldehyde. It's a preservative. If you end up drinking methanol, which I don't suggest, your body will generate formaldehyde and you will go blind. But this is trigonal planar. It looks like this. And then propanol, which can be used as a fuel. Prop means 3 carbons. We'll get to that later. You have 1 carbon, 2 carbons, 3 carbons. And then we draw OH at the end. If it's not a carbon, then we're going to write what it is because we need to specify.